In this lecture video, we'll be understanding Routh-Hurwitz criterion. The topics which is being covered in this lecture video is numerical based on Routh-Hurwitz criterion. So before understanding the numerical on Routh-Hurwitz criterion, we need to understand what exactly is RH criterion. For that, we need to know the conditions for stability. There are three kinds of systems: stable systems, unstable systems, and marginally stable systems. If all the roots of the characteristic equation lies on left half of S-plane, then the system is said to be unstable system. If the roots of the system lie on right half of the system, or right half of the S-plane, then the system is said to be unstable system. And if the roots of the characteristic equation lies on imaginary axis of S-plane, then the system is said to be marginally stable system. So to understand this, let me just annotate and will show you. If we consider an S-plane, we'll be having two axes, real axis and imaginary axis. Real axis and imaginary axis. Now, a system is said to be stable system if all the roots are present on left half of S-plane. The roots of the characteristic equation are present on the left half of S-plane, then that system is said to be stable system. Similarly, a system is said to be unstable system if the roots of the system lie on right half of S-plane. Somewhere over here, if it lies on the right half of S-plane, then those kind of systems are said to be unstable systems. Similarly, a system is said to be marginally stable if the roots lie on imaginary axis. If the roots lie on imaginary axis, then those kind of systems are said to be marginally stable systems. So using this basic knowledge, let us try to understand RH criteria. Let us consider a general characteristic equation given by A naught h to the power of n plus a1 h to the power of n minus 1 plus a2 h to the power of n minus 2, etc. up till an, which is equal to 0. Whenever a characteristic equation is given to us, we have to form an array, and that array is called as Routh array. So to form Routh array, we have to follow certain steps or certain methods have to be followed. The first one is identify the highest power of S. Here in our characteristic equation, the highest power of S is h to the power of n. So h to the power of n, h to the power of n minus 1, h to the power of n minus 2, h to the power of n minus 3 up till h to the power of 0. So we have to fill all these elements now. The first two rows of the Routh array will be taken from the characteristic equation. The coefficients of the characteristic equation, whatever we have, that will be placed in the first two rows of Routh array. A naught is the coefficient of h to the power of n, it will be placed over here. A1 is the coefficient of h to the power of n minus 1, it will be placed over here in our array. A2 is the coefficient of h to the power of n minus 2, it will be placed again in our first row. Similarly, it will be continued. A3, A4, A5, A6, A7 up till it ends. It will be continued like that. Next, after the first two rows of Routh array is filled, we have to fill the remaining values in a Routh array by using a formula. Here I have written as B1, B2, B3. How we get that B1, B2, B3 is B1 will be equal to A1 multiplied by A2. A1 multiplied by A2 minus A0 multiplied by A3. A0 multiplied by A3 divided by A1. So this is the formula which we use to find the value of B1. I'll repeat once more. B1 will be equal to A1 multiplied by A2, A1 multiplied by A2 minus A0 multiplied by A3, A0 multiplied by A3 divided by A1. Similarly, to find B2, we'll be using the formula A1 multiplied by A4 minus A0 multiplied by A5 divided by A1. The same thing is written here. A1 multiplied by A4 minus A0 multiplied by A5 divided by A1. Similarly, to find B3, A1 multiplied by A6 minus A0 multiplied by A7 divided by A1. A1 multiplied by A6 minus A0 multiplied by A7 divided by A1. So like that, we'll be filling the values of the third row. Similarly, to find the value of fourth row, I have simply taken as C1, C2, C3. How we get that C1, C2 and C3 is C1 will be equal to B1 multiplied by A3 minus A1 multiplied by B2 divided by B1. Similarly, C2 will be equal to B1 multiplied by A5 minus A1 multiplied by B3 divided by B1. The same thing is written here. C1 is equal to B1 A3 minus A1 B2 divided by B1. C2 is equal to B1 A5 multiplied minus A1 B3 divided by B1. B1 into A3. C1 will be equal to B1 into A3 minus A1 into B2 divided by B1. C2 will be equal to B1 into A5 minus A1 into B3 divided by B1. So this process will be continued till the coefficients for up till S0 is obtained, and from this array stability can be predicted. Now, how to predict the stability? To predict the stability using RH criterion, we will be focusing on first column of Routh array. So this is the first column of Routh array. So we'll be focusing majorly on this first column of Routh array. So based on the values which we have obtained on the first column of Routh array, the stability of the characteristic equation will be decided. If all the terms in the first column of Routh array has same sign, only then the system is said to be stable. There should not be any sign change in the first column of Routh array. Only then we can tell that the system is said to be stable system. If there are any sign changes in the first column of Routh array, then the system is said to be unstable system. And the number of sign changes will be equal to number of roots lying on the right half of S plane. So let me annotate and let me show you. So this first column of Routh array values, whatever we have got. So based on this first column of Routh array, the values which we have got in first column of Routh array, the stability will be predicted. If all the values of the first column of Routh array is not having any sign change, that means if all the values are positive, if one value is positive, all other values should also be positive. If it doesn't have any sign change, then that system is said to be stable system. For example, if in the first column of Routh array, if any value has sign change, for example, one value has positive sign, the other value has negative sign, then that there is a sign change which is present, then that system is said to be unstable system. So based on this stability considerations, let us solve a problem. Let us see how to solve a problem. Comment on stability of a system using Routh stability criteria, whose characteristic equation is given by s to the power of 4 plus 2s cube plus 4s square plus 6s plus 8 equals 0. And also predict how many poles of the system lies on the right half of S plane. If we observe, the highest power of S which we have here is 4, s to the power of 4. 4 is the highest power of S. So n will be equal to 4. Next, to find the coefficients A0, A1, A2, A3, A4. A0 is equal to 1 because beside s to the power of 4 we have 1. So A0 is equal to 1. A1 is equal to 2 because beside s to the power of 3 the coefficient which we have is 2. Similarly, A2 is 4, A3 is 6, A4 is 8. Always whenever a characteristic equation is given, to write the Routh array, we'll consider the highest power of S we have. The highest power of S we have is 4, s to the power of 4. So s to the power of 4, s cube, s2, s to the power of 2, s to the power of 1, s to the power of 0. So we have to fill all these values now. the first two rows of Routh array will always be extracted from the characteristic equation. So the coefficient of characteristic equation, whatever we have got, that will form the first two rows of Routh array. 1, A0 is equal to 1, A1 is equal to 2, A2 is equal to 4, A3 is equal to 6, A4 is equal to 8. We don't have any value for A5 according to the characteristic equation which is given. So A5 is equal to 0. Next, to find the other values, s to the power of 2 row, s to the power of 1 row, s to the power of 0 row, to find all those values, we'll be using that formula. So we already remember that formula, right? So to fill this value, 2 multiplied by 4 minus 1 multiplied by 6 divided by 2, which gives us 1. To get this value, 2 multiplied by 8 minus 1 multiplied by 0 divided by 2. So that corresponds to 8. And after this, we don't have any other values over here. After 8 and 0, we don't have any values over here. So that is nothing but 0. So anything multiplied by 0 is 0. So the value which we get is also 0 over here. Next, to fill the values in our s to the power of 1 row, 1 multiplied by 6 minus 2 multiplied by 8 divided by 1, which corresponds to minus 10. Next, 1 multiplied by 0 minus 2 multiplied by 0 divided by 1. So 0 by 1, 0 by anything is 0. And we don't have any other terms over here. So again, that value will again be equal to 0. To find the values in our s to the power of 0 row, minus 10 multiplied by 8 minus 1 multiplied by 0 divided by minus 10. That corresponds to 8. Next, minus 10 multiplied by 0 is 0. Minus 1 multiplied by 0 is again 0. So 0 by minus 10 is 0. We don't have any values over here. Hence, the next value here will also be equal to 0. Now, if you observe, we have got values in our first column of Routh array. So if we clearly observe, the values which we have got in our Routh array is plus 1, first column of Routh array, plus 1, plus 2, plus 1, minus 10, plus 8. Plus 1, plus 2, there is no sign change. Plus 2, plus 1, there is no sign change. Plus 1, minus 10, there is a sign change. One sign change is there. Similarly, minus 10 plus 8, again there is a sign change. So if we observe, there are two sign changes in our first column of Routh array. So because there are two sign changes in our first column of Routh array, if there is sign change, then definitely the system is said to be unstable system. So the system is unstable. Because there are two sign changes in the first column of Routh array, therefore, two poles lie on right half of S plane. So this is how we find the stability for any given characteristic equation using RH criteria. I hope that you have understood this video lecture. Thank you.